in this lecture series, we are going to discuss about the dimensionality reduction and feature extraction technique under the supervised and unsupervised learning. So dimensionality reduction technique and feature extraction are the techniques used to minimize the number of input variables in a dataset while retaining the essential information. So feature extraction transforms the data into a lower dimensional space to reduce the computation cost and prevent overfitting and improve model performance. Common techniques includes principal component analysis for various maximization and linear determinant analysis for the class separation and autoencoders. So coming to the key concepts and understanding the problem why we need this dimension reduction is to handle the data sparsity, and it increases the data sparsity, computational complexity rises, and model performance degrades, and distance metrics become less meaningful. So here the problem identification and the solution. So high dimensionality data creates a computation, analytic and visualization challenges in machine learning and robot application, and that's why we need this technique. So reduce this computation complexity by preserving the essential informations, enhance data visualization and interpretability, improve model performance and generalization, identify and select the most relevant features for the specific task. And coming to the approaches, we have these approaches. So before getting into approaches, we need to know the key concepts and techniques. So dimensionality reduction techniques includes the feature extraction, selection and extraction, reducing number of random variables under the considerations. And coming to the feature extraction, it creates new, fewer and more informative features from the original ones after merging or projecting them into a new space. And coming to the feature selection, a subset of a technique that selects the subset of original features without modifying them. And why this it matters, as we discussed earlier, high dimensional data can suffer from the curse of dimensionality, making it difficult for the algorithms to find out the patterns and increasing the training. So coming to the normal approaches, here we have PCA. PCA is nothing but principal component analysis, and this is an unsupervised technique that identifies relationships in the data and to project high dimensional data into a low dimensional data space with a maximum variance. Coming to the LDA, so here I am discussing about the LDA. It is a linear determinant analysis, whereas it is a supervised technique commonly used for classification to maximize the class separability. So PCA is principal component for the conversion of high dimension to low dimension with maximum variance, and LDA is a linear data. It is used to maximize the class separations. And next one is TSNE, that is nothing but T distributor stochastic neighbor embedding. It is a non-linear technique primarily used for visualizing high dimensional data. And next one is autoencoders, neural networks designed to learn a compressed representation of input data and often used for non-linear dimension reduction. So these are the major approaches we used for this feature extraction technique. And next main difference between this feature extraction and feature selection is feature extraction is nothing but generates new features, usually resulting in a non-reversible transformation, losing some information. Whereas in feature selection, it keeps the original features, making it idle when interpretability is crucial. So both approaches are vital in machine learning, image processing and natural language processing to enhance the data quality. And coming to this PCA, as we discussed, non-linear technique, and TNS non-linear technique. Filter methods, yes, it is used under the feature selection, selects the features based on the statistical scores. And Vapor methods, it selects the features based on the model performance used for specific algorithms. And the steps we perform for this feature is we select the variable selector and we go for the accuracy rate and comparisons. And next one, we have a prototype like implementation. We will be using an algorithm like this. we are using the Python language and we are importing the PCA model, and PCA we are using the two components, and yes, reduced will be fitting to the PCA, and we will print that and we'll look into that variance and to a statistical data. So in the next lecture series, we will discuss about the DB clustering and other types of clustering techniques in the unsupervised and supervised technique. Thank you.